Hello friends, myself Vikas Shakya and I welcome you all on my channel Varteta Learning Platform. And today we are going to discuss about the precision handling in Python. But before that, I would like to just remind you about one of the things that we discussed yesterday, and that was the generator functions and the partial functions. So in case of partial functions, you might have seen that we created a function and we bound some arguments to that function and we created another function. And we call that function using some values, right? So in that case, basically we created a function from a function. So partial function basically returns a function, right? So that function can be used to later provide the rest of the arguments, and while creating a partial function, you can provide the fixed number of arguments that you want to provide. So in case of generators, I don't need to tell you much. I think that what is the use. Simple use is like in case you want to generate some number series, then in that case you might use the generator functions. But when we talk about the partial functions, the use is again when to use it. That use is again very simple to understand. Suppose you have some function. This function is there, and in this function you have a, b, c, and d. It takes 4 arguments, and if you want that at some point of time, or you can say that in this function there are 2 arguments a and b, which will be taken from some database value or some input from the client or the user. But these 2 values like c and d, they can be like the values which which your program know. Basically they are some constants. So in that case you can use the partial functions. You can create a function, partial function, which already these 2 values bounded, which you have taken from the user, and then you can pass the rest of the arguments using that partial function, and you can bind these 2 values, these 2 constants later, right? So that way you can use it. So whenever there is a need, like some values in a function can be taken from some user or some other input, like some database or something else, but other values are they can be taken from some other source, or they are some constant. Then in that case you can use the partial functions, right? So those are just the simple use of the partial functions and the generators, and you know the basic concepts of using the generators and the partial functions. So let's move ahead quickly to our today's topic, which is the precision handling. It will be a very short video, very small video, so I will tell you everything very quickly so that you can understand what is precision, what is all about precision. So there are 3 functions to work on the precision values. Like if you have a value which is a float value, or you can say a double value, in that case you may need to work sometimes on the precision of these values. Like sometimes if you want to print only 2 digits after the decimal, and that too truncated, to the nearest value. So in that case you can use these precision things, right? So suppose we have to truncate this value and we want to see only the portion of the value which is before the decimal. Then in that case you will use the truncate function, the trunc function. And all these functions have been defined which are used for precision. They all have been defined inside this math module. So you need to import the math module first before you can work on the precision, right? So let's close all these one by one so that we can see the result one by one. So here if you want to see only the first portion, that is the portion before the decimal, then in that case you will use the trunc function. So if you use the trunc function, then what will be the output? The output will be simply 3, because 3 is the first part before the decimal. So it only displays the first part before the decimal in the floating point number, right? So this is the way it works. And if you have to, you can also use the math module to find out the floor and ceiling of the values. So let's see floor and ceiling how they are working. So if we talk about the ceil function, then what does the ceil means? Suppose this is a function 3.566, right? So this is more than 3, this is greater than 3, this number is basically greater than 3, slightly greater than 3. So if we talk about ceil, then it means then find out the number which is the least integer. Just listen carefully. Find out the integer which is least close to this value but smaller than this value. I mean, it should be smaller than 3.566 and it should be the least integer, smaller than 3.566. And you can easily understand that this integer is surely 3, because 3.566 is slightly greater than the 3. And if we talk about the ceiling of this 3.566, then the definition is the least possible integer which is smaller than this, right? Which is smaller than this number. So that number is 3 only, right? So in this case, if we print the ceil value, then the ceil will be 3. The ceil value will be printed as 3. But when we talk about the floor is just opposite of the ceil. In case of floor, in case of ceiling, we try to find out the number just greater than this. I just told you the reverse, I think. So just let me correct it. Ceiling means just a number which is just greater than this number, an integer which is just greater than this integer. So 3.566 is greater than 3 but smaller than 4. So if we try to find out the least integer which is greater than this 3.566, then that integer would be 4. Okay, so this value math.ceil should print 4, and floor is just reverse of that. In case of floor, we need to find out that greatest value which is smaller than this. 3.566 is greater than 3, but if we say that we need to find out the greatest number which is smaller than this, then in that case that number should be 3, right? So this ceil will be printing 4 and this floor should be printing 3. Okay, so let's see this. Okay, so 3, 4, 3. 3 for truncation, and then ceil has printed 4 and then floor has printed 3 again, right? So I think you have understood this one. This is simple. I just earlier I just explained it reverse, but just remember the definition of ceil and floor. So for your information, I just want to put this definition here. So ceil means a smallest number. Ceil means the smallest number, smallest integer greater than the given floating point number. Okay, and when we talk about the floor, floor means the greatest integer smaller than the given floating point number. So this way you can easily remember this, and this should not create any more confusions in your mind. Okay, now there's few small things are left there. How to print the precision of a number. So if you have to do that, suppose I want to print only 2 digits after the decimal, and that too truncated to the nearest possible value, rounded off value, then in that case I can use this way, percentile point to f, and then close the quotes, and then percentile the name of the variable, this a. So this way it will print it. It will print like 3.57, because we have told it like you need to print only 2 digits after the decimal, and it also rounds off this. So it will print 3.57. When we come to this is also a format. You just give a colon and then point to f. Similar thing, just like this, but here we are using the curly braces rather than percentile. So this way you can use it, colon and then point to f means two digits after the decimal for the floating point number, and then we have called this format function, because you know this, I have already discussed this. These curly braces are used for providing the positional argument. So this is just a positional argument where I have provided this value a. So I have provided this value a, so it will take only 2 digits after the decimal, and it will also round off at the same time to this value. So this will also print 3.57. And here I have used round function explicitly, and this round function is also in the math module. So if we talk about this round function, then in this case what it will do, it will simply use this a, and then I have provided, like, after decimal I need to round it off till one place, right? So if I will round it off only after one place, then what it will be, it will be 3.6, because after decimal it's 5, and if you see the next digit is 6. So when we round it off for the first place, then it should be 3.6. I will add 1 to this digit, 3 point, so it will become 3.6. Okay, so this way it will work. So just need to close this so that we can see the rest of the things, the only things which we want to see. So let's see, it should print 3.57, it should print 3.57, but the last one should print 3.6. So let's see what happens. Okay, so you can see it's 3 because of this, and then it's 3.57, and then it's again for the next one, this is 3.57, and for the last one it's 3.6. Okay, so this way it works. So this was a small topic which you need to understood, and I just wanted to keep it simple for today. So that's why I picked this topic, so that we can just revise the previous video topic, like the generator and partial functions, why we use them, and after that I just wanted to discuss this precision things. So this was all about for today. So please like, share, and subscribe my channel, and share these videos with your friends, and let me know if you want anything else to be discussed here. Okay, so we'll meet soon. Till then, have a nice day. Bye bye.